So you have to classify the solids based on their intermolecular force. So what is the potassium sulfate? So if you see potassium sulfate is plus charge minus charge, right? It looks like ions, right? Na plus Cl minus, so it is K plus NSO4 2 minus. So in that case it will be ionic soil. Correct. Tin. Tin is a metal, right? So this is a metallic solid. Tin is generally used in the biscuits and food items container. This is a metallic solid. Next is benzene. Benzene, if you see, there are so many benzenes, they are held together by some weak van der Waals force. That's how the benzene is. Here I am showing 3 benzene held together by the weak van der Waals force. And since there is no poles here, right, this is non-polar molecular solid. Non-polar molecular solid. Why? Because here the constant particle is this molecules, benzene molecules. The next is urea. If you see this urea also has this, this has slightly negative charge, oxygen slightly positive charge here, right? This has slightly negative charge, slightly negative charge. You see there are poles here, and if you see urea also, the urea molecule is the one which is the constant particle, so it is polar molecular solid. Correct. The next is ammonia. Here also we will classify. If you see ammonia, you have this NH3. Nitrogen has a negative charge, all the hydrogen has a positive charge. Similarly, this nitrogen has a negative charge, all the hydrogen has a positive charge. There is a bond between this nitrogen and hydrogen. Correct? So this is also a molecular solid. This is also a molecular solid. I can say it's a hydrogen bond molecular solid also, because there is a hydrogen bond between nitrogen and hydrogen. Then we have water. Water is pretty clear, right? So we have this slightly negative charge on oxygen, slightly positive on this hydrogen, and it's a hydrogen bond between water and hydrogen and oxygen. So this is also a hydrogen bond molecular solid. Zinc sulfide. Zinc sulfide, if you see, there is Zn plus 2, S minus 2. That is ions. So it will be ionic solid. Let's take more example. Graphite. Graphite, we know the structure, it's a covalent structure. So it has to be covalent solid or network solid. The next is rubidium. Rubidium is a metallic solid. Next is argon. Argon is a noble gas, right? And it is a non-polar molecular solid. You have seen all the noble gas, all the gas are non-polar molecular solid. Silicon carbide, if you see such a complex structure, silicon carbide, it has to be covalent solid. Let's take some more numericals. Again, you have to classify this based on the intermolecular force. P4O10, tetraphosphorus dicoxide. So here also, if you see, it is one molecule. Correct? This is my phosphorus. This is my phosphorus, 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 phosphorus. 4 phosphorus, and the red ones are oxygen. So if you see this P4O10, this is a molecule, and there are so many molecules like this, and they are held together by van der Waals force. So this will be molecular solid. Next is ammonium phosphate. So ammonium phosphate, if you see, this is plus, this is minus, right? This is plus ions, minus ions. So Ionic. Why? Because they have ions are the basic building block. Brass is again a metal, so it has to be metallic solid. Again, to classify LiBr. LiBr is nothing but lithium with plus charge, bromine with the minus charge. This is the crystal structure. Since we have ions involved here, this is also ionic solid. P4. You see, P4 is a phosphorus molecule. There are plenty of or lakhs and lakhs of phosphorus molecules, and these phosphorus molecules are all there will be another phosphorus molecule like this. Right, like that, and they'll be linked by some wonderful force of attraction. The molecules are the basic building block here, so it will be molecular solid. The next is silicon. See, this is a silicon structure. There are so many silicons. It forms a network. So it is a network or covalent solid. So normally silicon and carbon, they form a network solid. Then we have plastic. Plastic is amorphous, it's not crystalline. Correct? This is my plastic, it's amorphous. The next question is, solid A is very hard electrical insulator in solid as well as in molten state, and melts at extremely high temperature. What type of solid is this? See, it is very hard. So it's very hard. So it will not be molecular. Molecular, or it will be. So it can be either ionic, or it can be covalent, or it can be metallic. Ionic, covalent, or metallic, yes. Molecular it won't be. Let me write full now. So molecular it won't be because it's very hard. Electrical insulator, so it won't be metallic also. Now option between ionic and covalent, right? So it is saying that it is electrical insulator in solid as well as molten state. So had this been ionic, it will not be insulator in molten state. We have seen in molten state, ionic breaks into ions and it conducts electricity. So it is not even ionic. So it has to be a covalent. Correct? So it is a covalent solid. Also, if you see, it melts at a very high temperature. Since it melts at a very high temperature, that proves that it has to be a covalent solid. Right? So the example of covalent solid can be diamond, graphite, silicon carbide, things like that. The next question is, ionic solids conduct electricity in molten state but not in solid state. Why? So we have seen this actually. So I have my solid state. This is my solid state of ionic solid. So you see, this is my Na plus ions, and the green one is Cl minus ions. These ions are very much tied together, right? They are not allowed to move. So they don't conduct electricity. There's no free ions or electrons. But in molten state, they break apart, right? This becomes Na plus. This is my Cl minus. So they have free ions in the molten or aqueous state. Since they are free ions, these ions are not free to move around. They conduct electricity. What type of solids are electrical conductors, malleable and ductile? So we know that metallic solids, we have seen this. The metallic solids are the only one which are electrical conductors, malleable and ductile. In fact, these two properties are only for the metallic solids because